Here we go. We're ready to tackle some more big bears. Today, we are going to look at reviewing some polynomial functions. Specifically, we're going to look at some operations involving subtraction and how much of a nuisance that subtraction sign can be, just making sure we get it distributed appropriately before we combine like terms. And then we're also going to get into where we're writing exact equations of polynomials given a graph. We're going to really focus on finding those zeros and one other specific point, and we'll talk about why we've got to find that point. So the first really challenging one, they're asking us to subtract this polynomial here from this polynomial here. And that we really want to highlight the word from, because I think that the word from tells you which polynomial you want to start with. Okay, so this is the one you're going to start with. So let's just rewrite that bear. So I got 3/5 x squared minus 2x minus 7/3. And now I got to subtract the negative 4/3 x squared plus x minus 5. And I think if we just establish the correct order, we've got a really solid chance of getting this problem correctly. Now the next thing I want to do is I want to distribute the negative. So it's basically this becomes a plus sign, and this becomes a plus, and this becomes a negative, and this becomes a plus. And now I'm in a position where I can combine like terms. I'm going to combine 3/5 x squared with 4/3 x squared. And I just encourage you to take advantage of the calculator. You know, we could sit here and talk about creating common denominators and all that jazz, but I think to be more efficient, we'll just plug that into your calculator, add the 3/5 to the 4/3, and you're going to get 29/15 x squared. And now I'm going to combine the negative 2x with the negative x to make negative 3x. And then we'll combine the negative 7/3 with the positive 5. And again, use your calculator, and that's going to give you 8/3. And this is the final answer that I have. Now, probably the biggest trick to this example here is that your first instinct may be to distribute the 4. But why can't you distribute the 4? Well, because your order of operations says I've got to square the quantity x minus 6 first. I got to take care of that first. Same thing here. You might want to distribute the negative 3, but you can't. Order of operations says I've got to square this first. So I'm going to take my time here. And the first thing I'm going to do is just rewrite the x minus 6 a second time. Minus 3. And then we'll go 2x minus 5. Rewrite it, repeat it a second time. Okay, so I've got 4. And then I'm going to start distributing the x, distribute the negative 6 to get x squared minus 12x plus 36. Okay. And then same thing here. Distribute the 2x, distribute the negative 5. And we'll get 4x squared minus 20x plus 25. Okay, now I'm going to distribute this 4 to get 4x squared minus 48x plus, oh my garage, let's go with 144, I believe. And then we'll distribute the negative 3 to get negative 12x squared plus 60x minus 75. And then we just got to focus on combining like terms. So how about this bear with this bear to get negative 8x squared? We'll combine negative 48x with 60x to get positive 12x. And then 144 minus 75 makes 69. And there is your final answer. But again, just order of operations. Make sure we take care of the squaring here first before you distribute your 4 or your negative 3. Okay, we're switching gears just a little bit here, and I'm just going to verbalize the directions here, and our goal is to write the exact equation of the given polynomial from this graph. And so the first thing we're going to take a look at are the zeros. We're going to take advantage of these zeros. And identifying the zeros, I think we've got a 0 at negative 3, so that's going to be the quantity x plus 3 is one of the factors. We've got a 0 here at 1, so that's going to be x minus 1. And 2, 3, 4, 5. And then looks like we got another one here at 6, so x minus 6. Now, what we need here is we need a y equals, and I'm still missing something, and it's this mysterious leading coefficient. We're just going to represent that by using the letter A. And now the question is, what is the value of that mysterious unknown leading coefficient? And this is where we're going to take advantage of this point that we have right here. This is negative 1 comma 3. I'm going to plug negative 1 comma 3 into the given polynomial and solve for A. And let's see what that looks like. So we'll substitute the 3 for y. Let's see, get my pen going here. We don't know a, and substitute a negative 1 for x. So negative 1 minus 1, negative 1 minus 6, there we go. So let's go, how about 2, negative 7. And if I multiply those bears together, I get positive 28. Divide that over. So 3/28 is a rather unsettling number, but it's the correct number nonetheless. So the equation that I'm writing, the exact equation, is going to be 3/28 times the quantity x plus 3 times the quantity x minus 1 times the quantity x minus 6. And this is what I consider my final answer. If we had more time, we could always graph this equation on the calculator just to confirm that it shows us the same graph that was given to us. Okay, again, I'm just going to verbalize the same directions. Our goal here is to write the exact equation of the given polynomial right here. And this particular graph has one of my favorite characteristics, and that's a bounce. We're going to talk about how we're going to handle that bounce. You always got to keep your eyes peeled for bounces. So let's start with our roots here. It looks like our first root is at, let's see, this would be negative 5. So we've got the quantity x plus 5. And then we've got the negative 2, so we've got the quantity x plus 2. And then we've got a bounce right here at positive 3. So the quantity, let's see, the quantity x minus 3 squared. So because of that bounce, we've got to make sure we've got a squared sign there because it's a repeated root. And again, we need y equals, and we have the unknown coefficient of a. Now, to find the value of a, we're going to use this point right here, which is 1 comma negative 4, and we'll plug that point in and see what we get for a. Go ahead and try to do that on your own and see if you get the same value I end up getting here. So a quick recap here, you'll see I substituted the negative 4 for y, the 1 for each of the x's. Just evaluated each of those, multiplied them together to get 72, and then divided that 72 over, and I reduced it. So negative 4 divided by 72 made negative 1/18. So just to put the finishing touch on this golden bear, let's say y equals negative 1 over 18, quantity x plus 5, quantity x plus 2, quantity x minus 3 squared. And there's my final answer. Just like we said earlier, if we had more time, we could graph this rascal on our calculator here to see if it matched the same graph that was given to us up here. All right, hope that helps. We're gonna tackle some big bears here in class coming up, and we're just getting one step closer to that elusive perfect score on the Regents exam.